everyone, welcome to my channel Chemical Engineering. Myself Dr. Kirti Zare. Today I am going to explain you about that what is exactly Euler's method, which is generally useful for the ordinary differential equations. This is the simple but yet powerful methods to solve the complex problem up to the approximations method. It is again used into the heat transfer, mass transfer, in the reactor designing, which is involving into the PFR, that is the plug flow reactor, CSTR, that is the continuous stirrer tank reactor, and so on. So it is applicable to the different type of the chemical reactors which is involving into the industrial system. So let us solve the problem that dx by dy is equal to the x minus y square for a given boundary condition, that is x0 is equal to the 0, y0 is equal to the 0. Find the y at x is equal to the 4 and take the size. It is also called as a step function, that is equal to the 1, right? So generally this size or the step function is indicates the accuracy of that particularly numericals, right? Whenever this particularly factor is into the less value, so you can h value become the lower, so you can consider this curve fitting or the solution of this complex equation become the more accurate, right? Again here x and the y, these are the limits, or else you can considering the boundaries they are given, right? Here video I had explained the different modes of the heat transfer, and with respect to the conduction use the Fourier's law, right, to solving the different boundaries of the metallics furnace or the brick walls. So in that particularly form of the solid object, you can also draw the different temperature profile through the Euler's method, right, in the heat transfer. So let us start for this particularly problem. So now h is equal to, h is denoted as the step function or the size function which can be calculated xn minus the x0 divided by the n. So xn and the x0 is nothing but they have mentioned the upper and the lower limit or else the boundary condition, right? So now they have to the 1 and xn is become the 4, right? And x0 that is the 0 and n. Now n you have to calculate here. Now n become the how much iteration that you have to conduct over here, right? So just by simple calculation you are getting the n is equal to the 4, right? At that point h is equal to the 1, right? Means you have to do the iteration up to the 4. See, these are the all approximate type of the method, so in which you have to consider the iterations, right? So just go for the iteration number 1, right? That is the x0, right? Become the x0 value become the 0, but through this Euler method x1 is equal to the x0, that become x0 plus the h, right? So x0 value become the 0 plus h value become the 1. So x1 become the 1, right? X1 become the 1. Now let us start for the calculation of the y0 as y0 plus h, which is the function of the x0 and the y0, right? Because here you are going to consider the y1. So before that value is initial iteration, that become the y0 plus h, which is the function of x0 into the y0. So let's put that value, that y0 become the 0 plus h is the step function. Now it is the function of x0 into the y0, and they are giving the function in the form of x minus the y square. So you have to suppose to take this form of the equation over here. So it become the x1 minus y1 square, because you are going to calculate the y1 here, right? So if you are going to put the all value, so it become the 1. So let's start for this. y0 value become the 0 plus h become the 1, which is the function of the form of the x0 minus y0 square, right? So here value become the 1, which is the function of x0 value become the 0 minus y0 value become the 0, right? So 0 plus 1, here again 0. So this value become the 0. So y1 value become the 0, right? So whenever the x1 value is equal to the 1, so at that time y1 value become the 0, right? This is the one calculate for the second iteration. So it become the iteration number 2, right? So in that you have calculated the x1 value. Now you have to calculate the x2 value. So it become the again x0, it become the x1. So how can you calculate it? That is the x1 plus 1, right? So x1 value become the 1 and step function become the 2. So your x2 value become the 2, right? Let us calculate for the y2. y2 is equal to y1 plus h, which is the function of the x1 and the y1, right? So y1 value become the 0 plus function, this is the function of x1 into the y1. So you can write the x1 minus the y1 square with respect to the our given equation. So 0 plus 1 into bracket x1 value become the 1 minus y1 value become the 0. So 0 plus 0 into bracket 1. So y2 become the 1. Let us start for the iteration number 3. It is equal to the x3, that is nothing but the x2 x0 plus h. So it become the x2. So x2 value become the 2 plus 1 is equal to the 3. So x3 value become the 3, right? Now calculate for the y3. So y3 become the y2 plus h, which is the function of the x2 minus y2. Now y2 value become the 1 plus h is equal to the 1, which is the function of the x2 minus y square. So x2 value become the 2 minus y2 value become the 1, right? So it become the 1 plus 1, 2 minus 1. So it become the 1 and this value become the 2. But for the iteration number 4, right? So in that you are supposed to calculate the x4, because here the iteration is equal to n is equal to the 4. So for the iteration number 4, x4 is equal to the nothing but the x3, that is nothing but the x0 plus the h, right? So it become the, now what is the value of x3? That is the 3 plus step function is the 1. So it become the 4, right? So x4 value become the 4, right? Now that become the y3 plus h, which is the function of x3 minus y3 square, right? So now y3 value become the 2 plus h is equal to the 1, which is the function of the x3. x3 value become the 3 minus y3. Its value become the 2 square, right? So whenever you are going to solve this 2, that is the 2 plus 1 into bracket 3 minus 4. By solving this, you are getting the y4 value become the 1. Right? So this is the y4 value. Whenever the x is equal to the 4, at that time y4 is equal to the 1. Right? Okay. So this is the complete solution of this particularly type of the function, that is the x minus y square, by the given boundary conditions. Right? So whenever there is a complex problem, so through by plotting the proper curve, you also understand that what should be the profile or what should be the nature of that particularly curve, which is noted as x. This function, that is the x minus y square. So please like, subscribe my channel, that is the chemical engineering. Please share it, and if you want to solve the any different form of the differential or maybe any function, so please put into the comment box, so I will get the solution of that particularly problem. Thank you so much.